Hello everyone, welcome to my poster presentation. I'm Himanshu Shekhar Das, and the title of my presentation is Impact of Effective Grid Impedance on Inverter-Based Resources Plant. So the motivation of my research is to find out the reason of, uh, of the grid disturbances when a large number of inverter-based resources are connected to the grid. So to explain the theory, let's look at figure one, and corresponding equation is the first equation. Here you can see that multiple number of grid IBRs are connected to the grid using same transmission line, and the grid impedance is shown here. If we assume that all the IBRs are feeding the same current to the grid, um, uh, and the equation becomes simpler, and the equation is like that, and the voltage at PCC, it can be represented by this one. That means the grid impedance RG and LG, they get affected by the number of IBRs. If the current feeding to the grid is same for all the IBRs. Okay, so based on this concept, um, I have come up with a simulation setting here, and what I did is I used a frequency sweep simulation, and here I tried with different type of filters, as we know that different type of filters affect the grid differently, and also I have applied different grid strengths for strong grid, for moderate grid, and for weak grid. Okay, so let's analyze the results here. So the first row is for L filter, second one is LC, and third one is LCL. And I have done it for three different grid strength: strong grid, moderate grid, and weak grid. So if we look into the results, what we can see is for L filter, there is no resonance here. So it just only affects the voltage harmonics when number of IBR increases. But for LC and LCL filter, there are there are higher impact. LC and LCL filter has a resonance frequency, and as the number of IBRs increases in the IBR plan, the resonance frequency decreases. That means with a higher number of IBRs, the resonance frequency, it can interfere with the controller frequency of each IBR. So if that interferes with the controller frequency, it may cause unstable operation. Okay. Same thing happens for same number of IBRs, but with lower grid strength. So if you can see for this for strong grid, for highest number of IBRs, resonant frequency is at like 2 kHz, but for same settings, the resonant frequency for weak grid is around 1 kHz. So from this result, we can come to a conclusion: as the number of the IBR connected to the grid increases, PCC voltage impact becomes more imminent. For LC and LCL filters, PCC voltage impact becomes critical at around the resonant frequencies, and that could be near the IBR current controller crossover frequency, thus affecting the IBR controller stability. Also, there is another thing. When we design the controller, we allow a 10% variation in the impedance parameters. But here we can see that with the variation of number of IBRs in the IBR plan, the parameter variation can be more than 10%. When this happens, then it can affect the operation of the IBR, and if this is not considered in the IBR controller design. Okay, so that was the main findings of my research until now. Thank you for paying attention, and have a good day.